Let's continue on with multiple choice review AB cumulative problems here. This is number 36. This is under differential equations. So we have our function f of x. It's going to represent the particular solution for the differential equation of dy dx equal e to the x minus 1 over e to the y. We're trying to find the value of f of negative 2. But to do that, we first have to get this out of a derivative form. So we're going to separate variables, take the antiderivative, and then use the order pair to help us solve for c. And then once we have that, then hopefully we have an equation that we can then evaluate. So first things first, let's separate the variables. I'm going to cross multiply. It may not get full separation, but at least it makes it easier for us to see if there's anything else we need to move. So if I cross multiply here, e to the y dy equals e to the x minus 1 dx. And if I look a little bit more closely, my dy and dx are sitting up in the numerator, so that's fine, that's good. And our x's are nicely grouped together on the right side, our y's are all together, so we've achieved separation of variables dependent on the left, independent on the right. We take our antiderivative of both sides. E to the u is just e to the u, so e to the y will just stay as e to the y. E to the x minus 1, these are two separate terms. We'll do our anti-differentiate separately. E to the x just stays e to the x. 1 becomes 1x, and then we have a plus c. So at this point, I'm going to go ahead and solve for c. So I'll take the order pair 1, 0. 1 goes in for x, 0 plugs in for y. And we get e to the 0 is equal to e to the first minus 1 plus c. Clean this up a little bit. E to the 0 is just 1. 1 plus 1 is 2. 2 minus e to the first power. So this is a number. We'll just leave it in that form. 2 minus e is just my c value. So I'm going to update my equation here. Replace the c with 2 minus e. And now I just need to find a way to solve for y. So if I take the natural log of both sides, I can then find a way to bring that y down in front. Once that y comes down in front, then I have my general equation. Or sorry, I have my specific equation because my c has been resolved, y is by itself. So now we can use this to evaluate y of negative 2. So negative 2 will plug in for all the x's. So we get natural log of e to the negative 2 minus negative 2, sorry, plus 2 minus e. Enter all this in our calculator. Y of negative 2 reduces to be 0.3486, and that matches answer choice B, or rather rounds to 0.349. All right, 37. Show that the slope field, or shown is the slope field for which of the following differential equations. So one of these differential equations is the one that's defined for all the, or responsible for all the slope segments that we see all across this section of the slope field. So I think maybe one thing we can do is look at some common properties. So a common property that I see is first and third quadrant, they're all showing negative slopes. Second and fourth quadrant are all showing positive slopes. So if we just plug in the order pairs, maybe we can eliminate a couple of wrong choices. But looks like that is not going to get us very far, just because these all are still kind of giving us some vague feedbacks. So I'm going to just turn to some order pairs here. I see an order pair here. Negative 2, 2 is a very steep positive slope, maybe a slope that's like 3 or 4 or 5, but it's obviously a positive slope. So I'm going to plug negative 2, 2 into each of the differential equations and see if the result I get matches with what I see here. So if I plug negative 2, 2, I get negative 2 plus 2, which is 0, so that's obviously not 0. I can eliminate that. Negative 2 times 2 is negative times negative 2 times 2. 2 negatives becomes positive, positive 4. So it looks like it's positive 4. Maybe we can keep that and continue on. If I plug negative 2 into my third option, I get negative parentheses negative 2 squared, which is going to be positive 4. 4 times 2 is 8 with a negative in front, so negative 8. That's obviously not negative 8. And then the final one, I get negative parentheses negative 2 over 2. That's a positive 1. And that looks a little steeper than positive 1, so I think 4 is going to win out with option B. Okay, let's look at 38, another slope field problem. Which of the following could be a slope field for the differential equation y cubed minus x? So what we can do here is we can look at some of the properties here. And some of the properties that I notice is that for y cubed minus x, I know that when y is, or when x is 0, right? When x is 0, I should be getting something in terms of y cubed. So when x is 0, I'm not necessarily going to get 0. So that's something that I notice. So when x is 0, y cubed should produce positive slopes above the x-axis and then negative slopes below the x-axis, right? Because if x is 0, that means on the y-axis, y is going to be dependent on whether it's above or below the x-axis. My resulting value is going to be either positive or negative slopes. So basically, on the y-axis, I shouldn't be getting any 0 slopes. So I see a bunch of 0 slopes here, and I know that also below I should all be getting negative slopes, because if I was negative 2 or negative 3 or negative 4, negative 4 cubed is still negative. So a lot of these we can eliminate. And then once I'm down to these two, then I'm looking at more specific order pairs. For instance, like here, that looks like it's 0.9, 0.9. That order pair 0.9, 0.9, I should be getting a positive slope, and rather than, am I getting a positive slope, or am I getting a slope that is closer to 0? So if I put in 0.9 cubed minus 0.9, I'm gonna get a 0.9, negative 0.9, and so that value, that negative slope, matches better with B than it does A. So once you're down to 2, then maybe just go ahead and identify an order pair that looks different, and then plug that order pair in to your differential equation and see what that result gives you, and then let that result guide the choice that you want to make between your two options.